Hello friends, in today's lecture we will discuss division by power of s of inverse Laplace transform. So let us see the theorem of division by power of s of inverse Laplace transform. Here is the theorem. Theorem इस प्रकार है कि if L inverse of fs equal to ft, if ft is sectionally continuous and exponentially order such that limit t tends to 0 ft divided by t exists such that s is greater than true, then L inverse of fs divided by fs, L inverse fs divided by s equal to 0 to integration over 0 to t fx dx, or L inverse of fs divided by s equal to integration over 0 to t ft dt. Again, I repeat the statement of division by power of s of inverse Laplace transform. Result is like this: L inverse of fs divided by s equal to integration over 0 to t fx dx, or L inverse fs divided by s equal to integration over 0 to t ft dt. देखिए proof. For the proof of this statement, let us suppose that gt equal to integration over 0 to t fx dx, whatever the right hand side here. gt equal to integration over 0 to t fx dx. This is equation number 1. Now from equation 1, अगर डिफरेंशिएट करेंगे इस इक्वेशन को, we will get g dash t equal to ft, because इंटीग्रेशन एंड डिफरेंशिएशन शुड बी कैंसिल, तो रिजल्ट जो हो जाएगा इसका लिमिटिंग वैल्यू जो हो जाएगा आपका gt हो जाएगा. सो g dash t equal to ft एंड लिमिट अगर 0 पुट करेंगे, g ऑफ 0 का वैल्यू कितना हो जाएगा, राइट हैंड साइड भी 0 हो जाएगा, सो इट इज 0. तो ये इक्वेशन नंबर 2. नाउ वी नो दैट फ्रॉम Laplace ट्रांसफॉर्म ऑफ डेरिवेटिव्स ऑफ Laplace ट्रांसफॉर्म से हम लोग जानते हैं कि L ऑफ g डैश t का जो फॉर्मूला होता है, L ऑफ g डैश t इक्वल टू s इंटू L ऑफ gt माइनस g ऑफ 0. Again, I repeat the derivatives of Laplace transform. L of g dash t. L of g dash t equal to s into L of gt minus g of 0. Now we know that the value of L of gt as it is, and g of 0 का मीनिंग हम लोग अभी जस्ट ड्राइव कर चुके हैं इक्वेशन 2 से. g of 0 का मीनिंग 0 होता है, so substitute here 0. So finally we get L of ft. L of ft equal to s into L of gt by using equation 1 and 2. Because g dash t का जो मीनिंग होता है, g dash t के प्लेस में हम लोग ft सपोज कर लिए हैं, पुट कर दिए हैं, s as it is, L of gt as it is, and g of 0 का मीनिंग 0. So it is L of ft equal to s into L of gt. Now fs equal to L of gt को आप fs ड्राइव कर लिख सकते हैं, fs and fs equal to s into L of gt. Now by using the inverse concept, L inverse of fs equal to ft, L inverse of fs equal to ft, that implies L of ft equal to fs. तो L of gt का जो मीनिंग हो जाएगा fs डिवाइडेड बाई s, और राइट हैंड साइड शिफ्ट कर दीजिए L को, L इनवर्स ऑफ fs डिवाइडेड बाई s इक्वल टू gt, एंड gt इज इक्वल टू 0 टू t fx dx, क्योंकि इसको हम लोग इक्वेशन 1 में सपोज कर चुके हैं. सो दिस इज द प्रूफ ऑफ द थ्योरम ऑफ डिवीजन बाय पावर ऑफ s ऑफ इनवर्स Laplace ट्रांसफॉर्म. नाउ अनदर थ्योरम बेस्ड ऑन द डिवीजन बाय पावर ऑफ s मीन्स अनदर इंडेक्स ऑफ s. अब देखिए यहाँ पे सेम स्टेटमेंट, इफ L इनवर्स ऑफ fs इक्वल टू ft, देन L इनवर्स ऑफ fs डिवाइडेड बाय s स्क्वायर इक्वल टू इंटीग्रेशन ओवर 0 टू t 0 टू y fx dx dy, और L इनवर्स ऑफ fs डिवाइडेड बाय s स्क्वायर इज आल्सो नोन एज 0 टू t ft एंड dt स्क्वायर. इस तरीके से भी आप लिख सकते हैं. दिस इज द अदर इंडेक्स हियर. Power of s is s square. So by the same way as the theorem 1, gt. First of all, suppose that gt equal to 0 to t 0 to y fx dx dy. This is equation number 1, and after differentiating this part we get g dash t equal to, because the first derivative has to be cancelled, 0 to t fx dx, and again the second derivative g double dash of t equal to ft. This is equation number 2. Now from equation 1 and 2, g of 0 equal to 0 and g dash of 0 is also equal to 0. This is equation number 3. Now we have the equation 1, 2, 3. We know that from derivatives of Laplace transform of derivatives, so L of g double dash of t, L of g double dash of t equal to s square L of gt minus s of g of 0 minus g dash of 0. Second derivatives of, again I repeat, the second derivatives of Laplace transform, L of g double dash of t equal to s square into L of gt minus s of g of 0 minus g dash of 0. Now on substituting all the above values of g of 0, g dash of 0, we get g double dash of t equal to ft. So L of ft equal to s square into L of gt by using equation 2 and 3. So L of ft is known as fs equal to s square into L of gt, as L inverse of fs equal to ft by the basic definition of inverse. That implies L of ft equal to fs. So L of gt equal to fs divided by s square, or L inverse of fs divided by s square equal to gt. So it becomes L inverse of fs divided by s square equal to gt, and gt is known as 0 to t 0 to y fx dx dy by using 1. So this is the second theorem, division based by power of s of inverse Laplace transform. Similarly, you can easily prove their generalized case. If L inverse of fs equal to ft, then L inverse of fs divided by s to the power n. We have already proved the first case, fs divided by s to the power 1. And the second case is L inverse fs divided by s square. And here is the general result, L inverse of fs divided by s to the power n equal to integration of a 0 to t dot 0 to t ft and dt to the power n. You can easily prove as the previous theorem. Based on these three theorems of division by power of s, another related theorems regarding the L inverse. L inverse of fs, suppose this one, L inverse of fs equal to minus 1 by t L inverse of f dash t. अब सपोज कीजिए कि ये स्टेटमेंट प्रूव करना है, L inverse of fs equal to minus 1 by t L inverse of f dash t. This is the another way of representation of inverse Laplace transform, a special case of result. This one, we know that the multiplication by positive power of s power of t is L of ft equal to fs, and L of t into ft equal to minus f dash t. This is equation number 1. This statement we have already proved when we discussed Laplace transform multiplication by power of t. So that is the statement of multiplication by power of s of Laplace transform, L of t into ft equal to minus f dash t. In terms of inverse Laplace transform of equation 1 reduces t into ft equal to L inverse of minus of f dash t. And t is as it is, and what is ft? Ft is L inverse of fs. So put here L inverse of fs, and what is L inverse of fs? This is here by equation 1 minus of L inverse of f dash s. So we get L inverse of fs equal to minus 1 by t L inverse of f dash t. So this is the special case along the multiplication along the power of s of in terms of inverse Laplace transform. So these are the 4 theorems. Now in the next video we will discuss the problems related to the above theorems. So thank you very much.